Degrees of freedom are the maximum number of logical independent values. df equals n minus 1. N is the number of items in a data sample. You can use the seats in this car to understand the degree of freedom. Think about 6 people will sit in this car. Only the first 5 people who entered the car have the freedom to choose the seat. The last person has no freedom to choose the seat. In other words, the degree of freedom equals 6 minus 1 equals 5. Practice 2. Find the degree of freedom for each question. Question 1. A die's manufacturer claims that a novelty die he produces is biased. To test the manufacturer's claim, one of the novelty dies is rolled 350 times, and the numbers scored on the die are shown in the table. A hypothesis test is conducted to determine if the manufacturer's claim is true. State the degrees of freedom. Number scored, frequency do not have degrees of freedom. Only data has a degree of freedom. We have 1, 2, 3, 4, 5, 6. So degree freedom equals 6 minus 1 equals 5. Question 2. A hypothesis test was used to compare the means of the two groups. State the degrees of freedom. Let's check the data. Male height, we have 1, 2, 3, 4, 5, 6, 7. So degree of freedom for male height is 7 minus 1 equals 6. Female height 1, 2, 3, 4, 5, 6, 7, 8. Degree of freedom for female height is 8 minus 1 equals 7. So the degrees of freedom for the test equals 6 plus 7 equals 13. Question 3. A hypothesis test was used to determine whether salad meals are independent of a person's position. State the degrees of freedom for the test. Let's check the data. Salad meals per week, we have 1, 2, 3, 4. 4 minus 1 equals 3. Check the data for rows. 1, 2, 3. So 3 minus 1 equals 2. Since we are testing the relationship, we need to do the multiplication. 3 times 2 equals 6. This is the degrees of freedom.